Notice my map. Tie in place. That's for already made positions, made in 0ply. I guess this is the only other place. Now these of course don't point to anything because, well, they are already made, right? And then if I do this, I have to fill in board was found by playing backwards from current board, I suppose. Current position. So a board.h already includes vector, so I'm not going to do that again. You can argue that I should, theoretically you can change board. It's an object, so now it uses vectors, tomorrow it doesn't. Well, this does use vectors. Okay, that's in principle, I guess you have to include the vector just because we use vector. Unless it is extremely clear, like we need to pass a vector to a member function as an argument of board. Then I know, of course, 100% sure that board will include that vector already. It would have to define the member function and therefore the argument. So yeah, but in this case, board does not necessarily, absolutely necessarily need to include vector, and therefore kind of should include it here as well. And then add edge is yeah. So turn this in a real class. I don't know what I'll run into, but probably need an currently I'm just passing an int, right? So the thing is constructed for the first time, then I just have the number of ply and an empty vector, which is, well, it's default constructed. You don't specify it in the initializer list here. And then I'll add edge to here. I can't type. Include data.h. This is a member function of edge of data, I mean, data. And then I want to add a iterator must be passed here, of course. It's a board. Points to a board. I'm gonna call it next board or something like that. And then here we have to add that to this vector. Is there any reason that this is definitely not going to add the same board twice? I think that would be very unlikely. I should only be calling this when we add the thing for the first time. Well, I don't know. I could add a check. Makes things slower though, like a lot. Although, nah, maybe not that much slower. I think I need to use a standard find here for searching in the vector. Let me look up how that works exactly. You can search by value type. I think this is the easiest thing. Yeah, so it's just possible moves begin. Parcel moves int, and then the thing that we want to insert, and that is going to return, well, that should return, it should not find anything, that should be able to end. So now they are unique. Yeah, and then I don't think I'll have all of them though. For example, so I guess I could run into one that is not inserted, but the number of ply is the same. In that case, I also should add it. I'm not sure. Damn it. Can this ever happen? I guess we need it's definitely not ply. Ply -1. No. What am I doing? So I'm having all positions that are made in n ply or k ply, say. We run over all those positions, and for each of those positions I find every position that from which we can reach this made in k ply position in a single move. And if that move is not worse than what we must have found before, no. If we found it before, for fuck's sake, I have no clue. Okay, let's say this is a position that is made in one ply. And here's another position that is made in one ply. And now we have a position here. It is made in 2 ply. And another position that is made in 2 ply. And another position that is made in 2 ply. And we're gonna link everything. I mean, that's maybe not even possible in chess, but I'm gonna say that you can reach every position from every position. So in any position you can reach, you can do a move and then reach the position that this thing is linking to. And then of course this is the mate position. I don't really care that that might be the same position. Let's pretend that it is just some position that is made. Must be possible to reach that, of course, from the O1. So I found 2 positions that are made, and then I found the adjacent positions. There's only one adjacent position for this mate and one adjacent position for this mate, and those are, I only found this, so these are new, which means that they are not O0. Because I found all O0s. Well, O is here actually just, you know, a dot here, but I can call them position. So I found all positions that are made in 0 ply, aka they are already made. Therefore, if an adjacent position, adjacent meaning that by just moving a single piece we can alternate between these two. So this is an adjacent position of that one, and this is an adjacent position of that one, aka there's an edge. And then this position was not found before, which means that it's not P0. And since there is an edge, it must be P1. So we add this one. And from here I find that one. Now assume that so the preceding boards are the preceding board is a vector with just this one, if that is current board, because there is only one. I think preceding boards are all adjacent positions minus the illegal ones, which I didn't draw to begin with. Now there's more going on. It was white to move. And over all possible legal preceding positions that the white king could have moved from. Just all of them are added here as well. So that's literally every legal move. But the black king previous positions are only returned if there wasn't an escape, say, for the black king. So the black king does not have a better move. That makes the preceding positions or also automatically the best moves, I think, right? Thus, this is a preceding position of that one, and this is a preceding position of that one. But this is not a preceding position of that one. Because why would you go from one ply to one ply? Now, if that was a black move, then... So if black moves between these two, then... this would not have existed. I think, yeah, this would be a P2 then. Because if black can move from here to there, why would black go there? Well, it's not even possible. Black can't be moving here. This is made, so here is black to move. So here's white to move per definition. Okay, then here's black to move. So you could say that if this is possible, that means that, oh, it could be possible. Okay, so say if black to move, and these are the only moves that black can do, then black would choose this one. Therefore, this is not a preceding position of that one then, because it has a better move, which makes this a P3. Which, I don't know, it's fucking, what the hell, why is this so difficult? Yeah, I think this whole graph is impossible. Odd means black is to move. So this thing cannot possibly exist, because the who is to move is part of the position. So there is just no way you can link from a position where black is to move and then do a move and then black is still to move. This is of course not possible. And here we have Okay, so given that this is made in 2ply, there must be links from P2 to P1. That's not even possible to have a link anywhere else, because this is made in 2ply, so you can always and only do moves to 1ply. Except of course when you go, you also have a possibility to move to 3ply, I guess, but you cannot move to 2ply. That's inherently impossible. And you can also not move to 5ply, say, because if there was a single move possible from 5 to 2, then the 5 wouldn't be 5, it would be a 3. So you can only do moves that add or subtract 1 from the number of plies that the position is made in. Is that correct? Well, link these things. You can just reach every position from every position, which is of course also not possible, but I think that works for this case. Oops, okay, so we find all of these, then we find all of these, and then we find for this position, say, this adjacent position and this adjacent position. And because these are new, that's not something I already found, I know that they are P2. And at the moment, for example, if this is the current position and these are the adjacent positions, then we add this link and this link, meaning that we can go from here to there or from here to there. Yes. Then this becomes the current position, and then we find these two as adjacent positions and preceding positions, because yeah, it's just possible to go from here to there and still go from 2 to 1. Every move it should be decrease 1. But now this position already exists. That means that this board already exists, because we added it in order to add this link. That's all there is. So I'm trying to add a board here, a preceding board. Two nodes, and it already exists, but I still want to add that link. How do I know that I need to add that link? It could have been going the other way. I mean, I think that, yeah. Let's take this one as an example. So all adjacent positions are all of these, but also all of these. If a position does not exist, then it must be part of this one, because all of these exist. And if the position does exist, then I still have to add a link if it is one of these, but not if it is one of these. I think I finally formulated it. Okay, let's put that in text, because this is also not clear. Yes, the board is the preceding position, so that would be D. How can it be anything else than ploy? Oh yeah, because preceding boards. So preceding boards is not really preceding boards then. Can also find a next board. Is it true? Yeah. I think preceding boards is just. Result. It's filled with adjacent boards. So it's just nonsense to call that preceding. Huh. 2 debug channels. Yeah, I guess I used preceding because it's a position that could have been the preceding board. But now I got confused and thinking that preceding meant that the number of plies is larger. So I think I still will rename it because apparently it's confusing. I guess I can do file wide find and replace. Or I could just learn Vim and know how to do that in one go. It's like you can record a macro and then by the time I found that out, forget it and never get it again. I think it's Q or something. Okay, I'll just try it. So Q1, recording. DFG I adjacent. Escape, I suppose. Q. And then the replay is, I have no idea. Oh well. It was fun while I lost it. Replay, okay, try something. Quote 1 maybe, or definitely not that one. I don't know what happened. Okay, what about single quote? 1. Nope. And also switch to troop. What the hell, dude? What does troop have to do with this? Ah, it's the add sign. Add 1. Well, that took a while, but now I can do this. However, I don't want to do it there. And yeah, we already got at the end then. So what do I want to do with the debug channel? The debug channel. This is used to print preceding boards. In which function? In generate. While we run over adjacent boards, that's what I mean. Preceding positions. Yeah, theoretically that information was already printed then by the call to adjacent positions here, which pretty much prints them all. Let's just not do this then. See, there's something really wrong here. It is not known to be made in fly. That's only true if it doesn't exist. I'm inclined to replace this with this. See if this compiles. No notes type. Oh, notes is part of graph. Yeah. Excusez-moi. Dus of undeclared identifier graph. Oh. Huh? Yeah, graph.h includes data.h. That's not gonna work. That's a circular header dependency. Can't include graph, I guess. Yeah, graph is totally not defined before data is defined. And nodes type can only be defined after data is defined as well. Okay, for declare this. Uh-oh. Gonna do the easy way out. Just do a code duplication for once. Yeah, so data is still incomplete here, which is probably not a problem for the nodes type. But I doubt that we can get a iterator from type def to something incomplete, or maybe, well, map is complete, of course. Maybe it still works. Probably. Hopefully. And that means that board might as well be incomplete. I'm just gonna do forward declaration for that. Yeah, but that sucks. This must be moved to its own header. This needs board.h to be included, because board doesn't have nothing to do with data, etc. So we can include that. I think I'm just going to move it to board. So a bit of a lazy way out, of course. Yeah. Kind of belongs in board, but on the other hand it doesn't. Cannot define it here because we call a member function on board, but we can define it at the bottom. So this is a compare between two boards. So you could say, okay, that belongs in board.h. On the other hand, I only use it for the map, which is purely a graph thing. That's why I would like to have it in graph. But now we also need it in data and blah, blah, blah. So I'm going to include board from data. We don't have to do that here because we include data already. And also map. It includes map as well. And then if I have data, actually, I can just use it from data. Code duplication resolved. Okay, so data now needs to include board.h. Applies a private member of data. Yeah, I need an accessor for that now. Current position iter. Hey, oh no, I didn't. Data, oh yeah. Added a new header, sorry, a new source file. So let's add data here. Let's put this thing in alphabetic order. B, C, D, another B, K, L, M, and O. Board does not have node types. It never had. Oh, this is my new file. Data has it. Oh yeah, type board. Well, it should have been graph, and then I moved it to data. So the code insist. I think it compiles, right? Yes. But yeah, it's hardly worth it to run it, because nothing changed, I guess. Oh, it did. Something changed. Not good. But my new file, so it's not that bad. It's not a regression. Don't add the same edge twice. I am adding the same edge twice. Aha. Adding an edge from. Pretty sure that's what I'm doing. Everything is off. I'm trying to print data now. Valid operands of binding O-stream data, yeah. Where am I trying to print data? This was not my intention. Debug O-stream operator. Trying to print a standard pair. Probably my edge thing, which I just added. Yeah. Yeah, of course. Can't dereference an iterator and think you don't get a pair. I want a board. Oh, that's a bit quick. That's very, very quick. It is turned on, so we didn't add any edge at all, and then it says, hey, you're adding an edge twice. I think this is the very, very first edge that I add, yes. Very confusing as well. Now we are here. It should at least have printed this. Didn't print anything. Sure. It's not printing anything. Oh, never mind. Never mind. I'm a forgetful person again. ABCD. Into chess. I turned debug off. Like everything was turned off. Yeah. It's like literally adding the same edge twice on a row. So you have to turn on the adjacent debug output to find out what is going on. Not clear, is it? Not clear. Does this also happen for an 8x8 board? Because this is such a big board. Well, maybe even for 6x6. Yes. Okay. This is the position that we are adding an edge from. That means that this is the one that is to move, right? Yeah. And black is to move. Well, where would black go? This is an adjacent board. I think we already know how many ply this is made. So let's continue searching for that board. What else is 3 times on a row here? It's already duplication. It's created from index 0. And then again created from index 1. Even this is printed twice. It's printing adjacent board and then added adjacent board. And that is the whole problem, apparently. That it appears twice. The same position is returned twice. Yeah, okay. I understand at least why. Not do this. I understand why this wouldn't crash then. So the problem is that we get the same positions. We get 2 positions that are exactly the same. That means that this added adjacent board is reached twice. Made in 3 position. How is this made in 3? It's made in 2. Fuck. It's totally made in 2, right? This king goes here, and then black has only 1 option, and then you give mate. Oh, that is made in 2. Yeah, made in 3 ply. Duh. Made in 3, but it's 3 ply. Yeah, okay, it's made in 3 ply, correct. And then, well, it's suspicious that everything is on the main diagonal, right? I think that's the reason that it goes wrong. Adjacent boards created from index 0. And why do I not get that in index 0 is... What index 0 is? When was it added? Maybe other debug outputs. Created from index. Okay, so we have adjacent board created from index. And that is then happening twice. For the same position. Because, yeah. Here the problem is that king moves is returning twice the same position. Oh, it's called king moves. Let's turn that debug output on then. It's just entering. Was it mentioned here again? Hi, Poise Bunny. I think I get it. Here you can see that it is different. King moves over there. So it's just trying to move the king from the corner to there and to there. That gives two positions. And both are added, but if you canonicalize this one, it's equivalent to the other one. Guess that is the reason, right? Can suppress illegal, is definitely not relevant here. So slightly confusing that king, there's a king moves called from king moves. There's a vertical line here, but I think it should more clearly say what is this. So does the king moves versus black to move? King moves does not call king moves, but it's called from here. Yeah, there's a recursive call here. Oh, that's this one, alternate. Yeah, okay, so since king moves is called, king moves does debug output, while really I want to suppress that if alternate is off. So maybe I should do something like you would think I have already a scoped object that I can use to either turn it off or not turn it off. Nou ja. Now it is readable. So we have this made in 3-ply position. And then we call adjacent positions. So we want to find which positions can lead to this one. Jesus, I move my mouse, it scrolls. Stop scrolling. It's just my scroll wheel. So we're just trying to find what the last moves with the black king were. Calling king moves for that board with color black. And then that's it, adding position with the black king move to 0-1 and to 1-0. Obviously, they're the only two things that it can go to. And that is the end of king moves, because we lose the indentation that we have here. So returning from there. Let's set the result also. Index 0 is the king move to 0-1. Index 1 is where the king moved to 1-0. So we're going to create a board now from index 0, meaning the black king moved to 0-1, which is there. And then you get this board, which is correct. King move the one down. and then it added that board, which is kind of silly because the same board is shown twice, so maybe I should not print it here. I don't know what's going on with that. I think I print all adjacent boards already, so then if I add it, I don't have to show it again, right? I'm gonna change this, I think. Like right now, or right now. And of course, we have 3 of those. Yeah, so we create in adjacent positions. I'm creating boards here, showing it. Default is valid. And then it was already printed, yeah. So valid might be set to false, might not. If valid, we add it. There's no reason to print it here. The creators form index is nonsense, isn't it? Well, actually, no. What? I have 2 indexes here. It's only when black was the move. Okay. I mean, the duplicates were only then. So we have the mate in 3-ply position, and then we call king moves from that. That always happens, and I might as well get rid of this duplication if you ask. But okay. So grid from index 0 here means that the king moved to 0, 1. And then it's just added without printing it again. And then the other one is created from index 1, so the king moves there, also added. And the problem here is that we are adding a flipped board and a non-flipped board, which actually are the same thing. This one is equal to that one when canonicalized. Yeah, what to do with that? Tough. Every mirrored position. Adding. I think it would be good for me to go for a walk, and I have something to think about now. Yay. To summarize it in my head though, otherwise I can't think about it. But the problem is how to only add unique edges. Right? It's pretty difficult, but okay, I'll have some time while walking. Yeah, I'll be back later. I'll stream again when I return and code the solution.